and he's a researcher at MSR. He's been there for about 4.5 years, and before that he got his PhD at UCSD. And this is actually a really cool project that I've heard a lot about, so I'm glad Neil could make it over here and give us this presentation.
Okay. Thanks for the introduction. Hi, everyone. So I'm going to talk about a couple things around what I'm going to call living photos. Some of this work, primarily two works, one that is fairly recent and one that is not even published yet and I haven't talked about before. So I'm going to try to keep it pretty informal. You can ask me stuff if you want, and fairly high level. So just before I go into that, a little bit more about me. I'm not actually really an HCI researcher, so talking to you guys is kind of fun for me because I'm really more of a computer vision, computer graphics researcher, but I've been doing a little bit more in HCI recently, and that's some of the stuff I'm going to talk about today. But here, just a selection of a few other things I've done. I started out working with large camera systems and camera arrays. This was at Stanford. So the idea here is you have 100 cameras, and you're trying to kind of get better images by aggregating across a lot of bad cameras. So you could do really wide field of view videos. You can do view interpolation, like bullet time type stuff. Done some work in photometric stereo. So it's kind of the less known stereo for people who've heard about stereo. The idea here is that actually you can use lighting changes to recover structure instead of things like binocular stereo. I've done a lot of work in deblurring, image processing, trying to recognize or measure the quality of images, improve the quality of images, and that's where a lot of my work has been the last few years. And then the other chunk, which is going to be more what I talk about today, is looking at sort of things you can do with bursts of images and short video clips. So when you think about living photos, there's a lot of terms for these things. People call them living photos. You've heard cinemagram, probably. We call them cliplets. They've kind of exploded in the last like 2 years or so, probably really starting with the work of Beck and Burke, who are fashion photographers. So these are, I think, from some New York fashion show. And you know, there was a cover of the iPad cover for Marie Claire was this sort of looping video. You've all, I'm sure, seen the Harry Potter movies, and you know, they're basically every photo, every painting is always moving. So that's kind of our vision is every photo should just be moving from now on. You know, let's not have static photos because why? You know, it's just boring. Of course, there's still lots of great static photos. But the thing about these is that these are actually really hard to make, right? So each one of these is an example of a professionally made living photo that had years of experience and thousands of dollars of tools and cameras going on behind it. So one of the things I've been looking at recently is trying to make it easier for casual users to make these, and also think about just what is this space, right? So if we think about this space between sort of still photos and videos, photos have this really great quality that they're fairly objective. It's really easy to see a photo. You can see, you look at it for a tenth of a second and you get it. Videos on the other side are kind of a pain in the ass, right? So lots of people will take the classic thing is they have the handy cam at the birthday party and they take like an hour-long video. No one ever looks at it, right? Even like a 1-minute video is just a pain. It's a pain because it takes a long time to watch it. And it doesn't really convey one thing. There's lots of clutter. There isn't necessarily one message unless you do a lot to it. So these things in the middle, these living photos, these cliplets, kind of give you this abstraction of video, but something richer than photo. And I think that's really, it's a really fun place to think about. It allows you to tell a little bit of a story, but not so much that you're creating a whole narrative. And I'll give you some examples of that. So there's a lot of previous work in this area. There's the professional stuff that I mentioned. There's a lot of research papers. A lot of the earlier work is about over 20 years old in just kind of create textures, so videos that just loop sort of on end, the way you think about a textured wallpaper for an image. That's what a video texture is. There's some newer work that probably has been talked about here, I'm not sure, but from Asim Agrawal in Adobe on sort of doing this interactively with moving scenes. So you want to be able to create loops, but remove kind of stabilize areas that are moving. And there's a whole bunch of apps. I think this is out of date. There's at least like 10 iPhone apps for doing this kind of stuff. There's a Nokia cinemagraph app. And then, of course, there's Premiere and Photoshop. So I kind of got interested in this space a couple years ago at this point. And one thing I wanted to think about is, where are we? Right? Where if in this sort of axis of things that are easy to use tend to limit how expressive you can be, and things that are expressive tend to be very complicated because they have a lot of controls. You tend to see this kind of trend. So I threw some things up here. This is my estimate of where I would say current technology is, and really we wanted to see, can we get out here a little bit, create some tools that are expressive but not quite as hard to use as Premiere, right? But they might still be a little harder to use than something that's completely automatic or just uses a simple touch. So the first work that kind of came up in this space, this was published last year at WIST, is what we call cliplets. So this is looking at really a very user-driven way of creating these types of semi-animated, moving, living photographs. And we wanted to explore a couple things here. So a lot of the initial work and a lot of the work you see out there has this kind of spatial juxtaposition. So you have something frozen and something moving next to each other. We also want to be able to play with time, so doing this in time. So here's a great example, right? Obviously, she didn't freeze in midair. She is stopping and then playing. So we wanted to create tools that not only allowed you to create these types of cinemagraphs, where some things are looping and some things are paused, but you could also sequence things in time. And then we want it to still be fairly expressive, but not too complicated. So this actually started as an intern project at MSR with an intern of mine 2 years ago. And this is kind of where we ended up at the end of the summer. So this guy, it probably, if any of you use Premiere, it feels a little, or After Effects feels a little similar. So it was inspired by that. It's a kind of a two-pane video editor. On the bottom here, you have basically time remapping functions. So that is, you'd select an area here, and you'd say, for this area here, I want to play it in a loop, right? And you could actually really draw anything out here. So this is just saying, this is the output time and the input time. So a straight line is just playing straight through. A flat line would be a still. This sort of sawtooth thing is a loop that plays forwards and backwards. But you could actually create any number of control points here and create really any function. And that's what you can do in After Effects as well. So we created this and started playing around with this. And what we realized is that we didn't actually need to have 100 control points, keyframe everything. We didn't really need to create weird, swoopy, sine wave motions. But that we actually really only needed to do, we found that most of the time we could do what we wanted. We could create the effect we wanted with basically 4 things. One is still. So this is just mapping some input frame and just holding it the whole time. So that's just a photograph, right? So you're saying one part of the region could just be still, and or one part of your image could just be still. The other is a loop. So these two together basically give you your cinemagraph. You have some part of the image that's stopped. You have some part of the image that's looping. Another thing we found is a lot of content doesn't loop very well. So like if I move my hand like this, and that's the end of the clip, and you loop that, well, it's going to disappear here and reappear here. Right? So that doesn't look great. But a really easy way to loop things so that it's smooth is you just reverse. So my hand will go like this. So that's a mirror loop. So we found that was really helpful. And then the other thing we find is we wanted to be able to just play segments of the video. So this is sort of more so you could do these sort of sequences of things. So in the one I showed before, we have this girl suspended in the air, and then at some point it plays, she falls, right? And after doing that, we basically just turn the whole UI around. We remove the time remapping functions. We created these individual blocks, and then created a new app. It looks like this. And this is kind of the current Cliplets app. This is what was in our paper. This is actually released publicly. And just to kind of walk you through it, I'm going to do a little live demo. So you can see how these building blocks go together and how you might create your own cliplets. So let's pull this up. Sorry, my laptop is pretty slow, so it will come up in a minute. Okay. So this is the Cliplets app right here. So there's still some elements of that initial design just reconfigured. Let me open a video and then I'll help me illustrate that. Let's do that one. So the top bar is your input timeline. So if I play that, this just plays this input video clip. And it just loops it. The bottom is your output timeline. So the way it starts up is actually a full frame still. So the default cliplet is a photograph, right? So then the way you now try to animate, so I think of this conceptually as starting with a photograph and adding motion in. You could think of it the reverse way. Let's say we want to make this water fountain move and loop, right? So in a very sort of Photoshop-y way, I would select this layer or select this region. And you see I created this layer here. It says it's a loop. And now this is telling me basically the mapping from my input to my output. So this is saying that this segment of the input video from here to here is going to get mapped in a loop again and again and again. And I can have it loop the whole way through. So let me show you that. Right, and now it's looping. So that's it for the simplest thing. Now, you can obviously get more complicated with this. You can also fix things. So maybe you might notice here there's a little foot I grabbed. What happens when you actually hit that play button is there's actually a bunch of computer vision algorithms going on running in the background to kind of help you get a better result. But they're not foolproof. So it tries to blend the boundary a little bit so you don't get a hard edge if you cut through some things. Actually, when I loaded the video, it stabilizes. So if you had your hand was shaking around, the video is stable. But still, you can mess up. So basically, this is a very interactive tool. If I want to fix that foot, I'm going to just redo the boundary there and rerun it, and the foot's gone. So this is pretty nice. I like this. This kind of gives you this like nice, serene fountain without this weird dude walking by looking at you. It's kind of cool. But you can have fun with it. So let's say we could grab this bird here. Let me circle around him. And one thing you'll see is this selection sort of persists through time. So I just kind of drew a fairly reasonable box there, but maybe it wasn't big enough, so you'd skim around and you can fix that. So if I do that now, what's going to happen? Well, it's going to do this sort of funny loop, right, where it disappears. So that's where these mirror loops come in, and let's do that. Right. So now it's going to maybe not do something that's totally realistic, but at least do something that is not annoying. And for certain things, actually, the mirror loops can work quite well. So let me show you one other. I'll show you how to make the one that was on my title slide. So this combines a couple different things. So again, open the video up, it's stabilized it. You can actually tell that it's stabilized. If you look at the edges of the image, it's wobbling a little bit. So, let's say I want to freeze her in midair. I can do that, right? And make Pinocchio here in the workshop loop. So I'm going to draw a little region around there, and then this is the tricky part where I need to find a good loop. So let's first see what happens if I actually pick a bad loop. Right, so this is somewhere where the edges don't really line up well. So if you see here, the foot's kind of down, foot's up. It's still going to loop, but you're going to get this jump. Right? So you probably see that. So the idea is you're going to go back in here and kind of try to adjust it, get it closer. But again, computer vision can help you. If you're fairly close, we have this refine button here. You hit that, and it'll actually look at the endpoints of the loop that you specified and adjust them. So it'll say, well, if we actually make this a little bit shorter, a little bit longer, I'm going to find something that actually is much more similar and a much better transition. And then, so we can look at that. This is probably going to work pretty well. But there's still a little bit of a pop. Then we can do even more. We can smooth that transition. So there's this little checkbox here. And that actually uses optical flow, tracks the frames, and warps them and fades them together. So now it's going to smooth out the transition a little bit. And you actually see, you get almost this little wobbly effect as it transitions. Already you can see some of the things that are difficult about this tool or about creating these things, right? So if you look here, right, the background is moving a little bit, and that's because you can't perfectly stabilize this video. When your hand is moving, because there's a lot of depth in the scene, there's parallax. So really only one depth is stabilized, and when you see really far back in the room, things are shaking around. And it's really hard to do a lot about that. The easiest thing to do is actually just cut that out of your scene, right? So I'm going to just trace this a little closer. And the next project I talk about after this helps address this a lot better in a more automatic way. So now I got rid of this part moving. It's still maybe a little off here, but not too bad. So just one more thing I'll add is the play layer. So this is just, she's suspended in midair, and maybe we want to give her some relief. So again, here I can slide this around. What I'm going to do is line up the beginning of this layer with where this still is from. So you can see this still is here. And say, play till right, let's say right there. I'm going to make this a play layer. And now, let's say about halfway through, she'll come down. So let's let it render. So you'll see the playhead's moving along. Where it hits that green region, right, it sort of plays that. And that's how you go. Now you can think about how you can build these things up. You can have tons of layers. You can have lots of little sequences of things happening. So the girl who's freezing in midair, it's a play. It pauses. It holds at the top. Then there's another layer where she comes back down. And then there's another layer for the boy walking in, etc. So let me close that down. Go back to here. Oh, not there. Sorry. Jump back here. OK. So as I mentioned, there are some things going on in the background to make this a lot easier. I'll just walk you through a couple. One is what we call temporal feathering. I'm not sure how visible this is here. But it's the same thing I showed with Pinocchio looping, is that if there's a little bit of a jump because your loop doesn't line up, it'll interpolate that, so you don't get as much of a little hitch. So in this one, you'll see there's a little bit of a hitch as like his beer glass kind of tips up. So in this one now, we basically have this endless beer, which would be awesome, but doesn't exist, obviously. The other thing is doing alignment. This is actually not exposed in the app right now, but it's something we did in the paper, which is that a lot of times if you have this region that's moving and you have a boundary going through it, you can sort of see the edge moving. So if you look here, his pant leg kind of separates as he moves out of that region. So we can do some things to align that, to remove that. And the last thing is to try to adjust that boundary you drew. So the way I had to crop out the background in the workshop to remove the motion, we actually have some things that can adjust that for you. So here you'll see that this the thing I drew actually gets a little bit of the water moving and the shadow on the rock, and it adjusts that to remove that. So here's just some more results. You saw the one up there before. You can do a lot of fun things. You can make candles that don't blow out, even though they did. You can endless cartwheels that duplicate people. You can get pretty fun with it. So this, as I mentioned, we released this about a year ago. So this has been available online. People have been using it. They've been posting to YouTube primarily. It does save as a video clip or an animated GIF, so some of them are on Tumblr as well. But so here's just a couple that people made. This one's pretty fun because obviously, this guy just dropped a bunch of rocks, right? But then he retimed the whole thing to create this wave. Yeah, there's a lot of these examples that are really fun. So I think we've had about 130,000 downloads or so. One of the things we wanted to do for the paper and for our own sake was actually just try to get a sense of, given these tools, we did a lot of our own testing and tried to evolve what worked and what didn't work. But we wanted to know what people were actually doing. So for, I think, at least the first 6 months it was out there, there was a built-in survey. So after you'd use the app twice, it would prompt you to take a survey voluntarily. And we just asked people a few questions about, how sort of Likert scale type stuff, how easy they found stuff, how many layers they tended to use, how long it took, and we found that the answer was good in general. That people found it fairly easy. It didn't take very long. Interestingly, also, most people didn't use very many layers, so we support really infinite layers. I think it's limited to 8, just so things don't get too full on the screen. Most people report they used about 2 layers, maybe 3 once in a while, but not much more. So with that, I would just point you to our website and hope that you guys will try it out. It's Windows only, so I don't know if you guys actually have Windows machines or Macs, but it's a free download. You can try it out. You can try and make your own. We are still working on this, and I can't say too much, but just keep your eyes open. There'll be newer versions fairly soon for some other devices. But this is really our research download. So this is really the kind of the thing that I made, starting with my intern's code. The stuff we're working on now is a little bit more, has more engineers on it. So this is probably a better example of probably, for me, this was at least the most polished research code I've ever written. So if that's interesting to look at it from that perspective, I encourage you to think about that. So any questions on this? Otherwise, I'll move to the next thing that is very, very related. OK, so this is the new stuff. This is actually going to be published in Siggraph in July. So this is not out yet. This is actually the first time I'm even talking about it. So what we're doing in this work is really, it builds on the Cliplets work a lot. And it was kind of informed by a lot of the things we realized when making Cliplets, which was that even though we did, I think, a reasonably good job of distilling down professional tools to make these animated photographs or living photographs. It's still fairly challenging to select the right region, to find the right loop. So we wanted to think, we kind of went back to a little bit to first principles to think about what actually is making a good cinemagraph. You know, what makes a good loop? When I say good, I mean in terms of, you know, you don't see any jumping when the loop happens, or you don't see, you know, people getting cut in half or things like that. Not, you know, we don't do any, we weren't thinking about anything sort of subjective in terms of composition or anything like that. So kind of just getting back to basics, right? Let's go back to our sort of, you know, time graphs. Now time is vertical. And think about just a whole video, or like one horizontal line in the video, right? So an input, if you think about just any video, you just have, you know, time marches forward. So what's happening in a loop? In a loop, you're taking this chunk of time and just repeating it, right? That's on the right. So that's the same thing that sort of loop or little sawtooth kind of graph represented in the cliplets work. So what happens is when you have a bad loop, when there's really a jump, is that really on those boundaries, you're going from, you know, some time, 5 seconds into your video back to the beginning. And at that transition, if those frames are not similar, you get a jump, right? So that should be fairly obvious. So here's just a full frame loop for this scene. And what you'll see is, you know, at some point, everything kind of flashes, right? Everything's just resetting. And that's because it actually is still fairly compatible, right? I mean, most of these areas actually don't change that much. So here, you know, it loops OK. The water might be OK. But these trees, you know, are moving a lot more. They're more unpredictable. So the loop has a lot more artifacts. So people have tried to address this problem in a couple ways before us. You know, the simplest thing is just to try to pick the best loop, and that's what that refine button does in cliplets. It just says, let's try to find somewhere where that jump is not too bad. So you can do that. You can do that for the whole frame, and that helps. And depending on your content, you can get some really nice results. So this is work from 2000. I think this was in Siggraph. So this is just this candle flame, and they're actually showing that they can jump from a bunch of different points in the input video and just create this flame that's always going. And that works pretty well because the flame kind of goes back in the same position fairly often. You know, if you can't loop that well, if things don't go back in the same position, you can do other things like crossfade. So blend between the beginning and the end, and Cliplets does do that. But you'll see here in this one, it actually, you get this, instead of this jump, you get this blur thing. And actually, if you've seen some of the Bing video backgrounds, sometimes they do a great job at this, and sometimes they don't. And sometimes you'll see, like, there's one with the leaves, where you see leaves disappearing and reappearing, kind of fading in and out. So some of the other work done at UW, actually, a number of years ago by Asim Agarwala, was kind of trying to do this video texture type of thing in a panorama. So the idea here is now your camera's panning. You want to create this looping texture, but you don't actually see the whole scene at the same time. You're getting all these little snippets of this time volume, and you need to construct something that loops in between there. So this is really, really nice work. What they did here is they essentially picked little individual loops for different regions, did it in a way so there wouldn't be too many artifacts between them. There was a bit of user segmentation, so they needed to be able to say that certain regions are still here, so only the part in the red is the thing they're going to try and loop. But this is actually, it's very computationally expensive. It takes a really long time to run this, but it works fairly well. Some of the more recent work is, again, even more UI driven. So this is work by Tompkin from a couple years ago. And here they do a bunch of processing on the video. They try to find regions that are moving and regions that are not, and then highlight those for you. So then you'd select, you'd click on this and say, oh, this is moving, I want to make this move. So that's how, you know, the two eyes are two different regions. You'd click on an eye. So kind of all of these things were inspiration for this new work about how do we make the cliplets experience a little bit more automatic, but still use what the user can tell you. So what our goal was really is to create something that can make basically cliplet type things. I'm going to say more cinemagraphs, so not necessarily having the time aspect, but just the looping versus static. Completely automatic, but where there's really basically no artifacts at all. It picks the perfect loop for every pixel in the scene. However, we still want to be able to control it. You know, there is some benefit to just automatically spitting out a video loop, but in the end, the idea is to create your content, not have a computer create it for you. So we want to still have some control. So one thing we could figure out is actually some segmentation, similar to the Tomoe Paper, where we know what areas are moving and what are not. So now, if we go back to this graph, or this plot that I'm showing you, we have sort of every region in the image. Instead of the whole frame looping, we have different parts of the input video being selected, different lengths. Some things are static. And then we're going to create this output video by assembling those together. So here you can see the longer loops loop less. The shorter loops loop more. The static thing that's in red is static, and that's your output video. So this would be a cinemagram where this area is static and these areas are looping, but at different rates, which you could do this interactively in cliplets, but with 4 regions, it's not so bad. But if you have hundreds of regions, then it's actually pretty tricky. And for complicated scenes, you do actually need that. Yeah, this is just what I was saying. So again, now we have to worry about these temporal jumps. So we still have the same thing as before, that a good loop is one where when you loop around, you don't have too much of a difference. However, now, since we're not doing this for the whole frame or the whole video, we actually have to worry about adjacent things too. So you might have, the left side of your image is looping with some tree, and the right side is looping with water. But where they touch each other, you can actually create an artifact that there wasn't there before, because these things are now looping at different rates. So now this optimization problem is not just about finding the best loop, but it's finding the best loop given what your neighbors are doing. This will be the one equation I have in the paper. So basically, this is what you're optimizing. You're saying there are these spatial discontinuities. Those are the vertical red areas. There's temporal discontinuity, so that's the jump at the end of the loop. And then there's another term that kind of balances a bunch of things out. But it basically says that we prefer things that are moving. So there's some penalty to picking part of your video where nothing's moving. Because in the end, if all we output from all of doing our optimization is a still image, we really haven't done anything very interesting. So this goes into this big graph cut optimization. The details are not very important, but the output of that is that now we're gonna basically have that graph I showed on the right. For each pixel in the image, we're gonna say there's a time that it starts in the input video. There's a segment from the input video that will play. That segment could be 0, so then it's still. And then that's it. That's how we'll create the output. So this is now the same result rendered with the output from that. You'll see there's still a jump. That's actually PowerPoint looping the video, not the loop itself. Or sorry, no. This is actually the input. This is the standard loop. Where there is a jump. The next one will be that. So I'll get to that. My bad. So that was the one I showed before. So full frame loop, there's a jump when it loops. After we run our optimization, this is sort of a coding of what we get. So this is saying the color is not that important. It's just to show distinction. But we have these different regions that have different periods. So the water might be a loop that's 2 seconds long, and the trees might be half a second long. But not only that, they're actually starting at different times. So if you map these 2 images back to what you would have to do in cliplets to create this, basically everywhere you see a different color, that would be a different region you would draw. Anywhere where these colors are the same, that segment on the input would be the same length. But if they don't have the same color here, they'd actually be shifted relative to each other. So this is, like hundreds or thousands of regions that you could draw. Now, for this particular example, maybe you could get away with less, but this is what gives you sort of the best quality. So now this is the result after using those periods and those start times. So you'll see that there still will be the PowerPoint jump, but you don't see that jump that's every few seconds, right? Basically, everything's just kind of moving, and just kind of keeps moving, and everything looks really nice. So here are just some more visualizations for a few different images, or a few different video clips. And you'll see it's pretty interesting kind of what gets out of it, or comes out of it. So we have these like piñatas, and you see that each piñata gets kind of its own label. We have these flags here. Different flags are grouped together. It does a pretty good job. And this, just to make clear, the user hasn't done anything at this point yet. They just opened the video. But I'll get to what the user could do later. But let me just show you a few automatic results. So these are just now, video full looping. Everything that we can loop is possible is looping textures, right? So you have these kind of sort of atmospheric water things. I don't know what those are, coral, but also some fairly complicated things like these taiko drummers. The machinery takes care of it. It can loop all of this really well. Here's a couple more results. So that's the water example before where I showed that it was actually blurring with the crossfade. Because the loops are really good, we don't actually have to do really any crossfading anymore. So you don't see that blurring anymore. And we have this guy endlessly crimping. I think this is a fan in Japan. So these are pretty nice. And this is, drop the video in, spit it out. It does a pretty good job. We've run this for hundreds of videos. But there's really no user in the loop here. There's no creative control at all. There's no aspect of this cinemagraph. I can't pause anything in an interesting way. So that's where kind of now a little bit of the HCI comes in. We got to this point, so this is great, but I want to be able to still control it. I would like I want to be able to create something that looks more like a cliplet that has some control over it. So we addressed that in two ways. We thought, okay, well, we have all these regions. Can we create maybe just a single slider that gives you some options? And thought about, okay, what is the most logical slider? Well, how about static to animated, right? So one side of the slider is your photograph. The other side is everything's looping. And in between, you're basically going to get these cinemagraphs. You're going to have things that are some areas are looping and some are not. So run some more optimization to basically create that ordering. And then now you can get what we call a progressive video loop. So this is just, the slider is just drawn in, but this is literally a user sliding up and down. And as you see, if we get to this midpoint here, things stop moving. So as I ramp up, the water moves and the trees move, and as I back down, the trees stop and the water stops. So you get these intermediates that are a lot more like cinemagraphs, where you have sort of motion juxtaposed with still. Here's another example that should be even clearer. As you sort of slide the slider up, the wheel starts moving. The dripping water fountain kind of area on the left moves a little more. As you back down, that pauses. The wheel's still moving. So now this is just another way to think about exploring this space. The computer vision algorithms have really done all the hard work for you and just given you options. Right? So you can just say, I like something that everything's moving. I like things where half the things are moving. And this is basically what we call progressive dynamism. So it's this idea that there's something we've created where everything's moving. There's something we've created where nothing's moving. And that static loop is actually not necessarily part of the input video at all. It's assembled from different parts of the video in a way that you don't have weird edges. And then you can have things in the middle where things are static and things are looping. And this is all actually just parameterized by what we call this activation threshold. And it just says where on the slider should I turn things on so that I get kind of this balanced motion across the spectrum. So here's a couple more of these ramps with different types of imagery. And I'll just let it go a couple times. So you'll see like in that concert up top, when the slider is towards the left, you have fewer lights blinking. As it goes up, the lights start blinking more. You actually see people, it's hard to see on the screen, but you see people jumping up and down as the slider gets all the way to the right. The waterfalls, different parts of the water stops and starts. The flowers, certain different parts of the flowers stop and the water stops. So we like that. That's pretty good. That's a nice simple thing. You open your video, you have a slider. You can imagine even just doing a couple options. Here's the thing that moves a lot. Here's the thing that moves the least. Here's the thing in the middle. Right. So we're then thinking, OK, that's great. But what if I want to really get in there and say, like, this thing's got to stop and this thing's got to move? Well, we can do that too. We can process all this data into basically a bunch of regions that we know that can be started and stopped independently. They can be looping and paused independently. And so that's kind of what this looks like here. We do a bunch of processing here, and we say, OK, here's a bunch of regions. Any of these regions you can loop or make static independently from each other. So here's sort of the next UI. And let me explain what's going on here. So this is first of all, as the slider goes up, let me actually restart this. As the slider goes up, it actually is showing you what's paused versus playing, so green versus red. And then you can actually go in, it's showing you the regions, and with the mouse, click things. So I click those flags up there and stop them. I drew a stroke, and I'm going to say stop all of those flags over there. And that's basically the idea. So now we've gone from selecting a whole region to just tapping on a region or swiping through a region. I'll just show a few more examples of that. So in this one, the regions are actually a lot bigger. Right, so there's these big regions for these trees here. The trees are looping at the bottom. The trees at the top are still. And now the user's completely controlled what's going on. And here's just one final one. You want to say stop the water flowing over there, the steam over there. So you just go through and give it a little stroke. So just kind of comparing to some other work to give you a sense of how this compares. So the recent work from Asim, or by et al., but Asim was a co-author at Siggraph, was looking at doing a similar type of thing. They wanted to sort of handle trying to do stabilization. So you have to do a bunch of strokes to say what should be moving, what should be not, what should be stabilized. We can really kind of, with all of our machinery, take their data and produce something that's still pretty good. It's not exactly the same thing, right? So we haven't stabilized the whole glass, but we've created a loop where the glass is moving in a nice way. The guitar, the whole guitar is moving, but actually maybe it's more natural, maybe not. It's sort of subjective. But the main difference is these results here are completely automatic. You can still go back and use the interface that I talked about, but you don't have to. And here's another result, again with one of their data sets. Also showing the strokes there, and then for this one there's no strokes. However, if you wanted to, you'd still go and say, let's make that hair not move, for example. And then this is just a comparison to the Tomoe Paper. Again, it's a different result, but maybe fairly equally good, but no required user input. But still, you could go and click on the eyes and do something like that. And just one more here. This highway one's actually pretty cool because these are all different regions. So you really could pause this lane and have that lane move, or pause that lane and have the other one move. So that's kind of fun. There are some limitations, and these are still some of the limitations you see in cliplets, and they remain here. If you have things that are overlapping each other a lot, like these trees, right, you'll see that this branch kind of appears in both sides it's really hard to do anything about that. One thing that I found when you're actually, I've obviously been taking a lot of videos for making cliplets and things like this. You start to sort of see things a little differently. You think about like, oh, I'm looking out in the world and I want this thing to loop and I want this thing to be static. So I'm going to stand here so that they're not overlapping each other. And you start doing those things, and just like any photographer, you can fairly easily learn how to take things, shoot your footage to avoid these problems. Some of these other seams and blending things are still hard. It's hard to blend moving water into fog. I mean, there's certain things that you just can't match together. There's also cases where you can just completely violate any reasonable semantics. It doesn't look bad, but if you see this boat here, the boat's going like this. But boats, boats are, hopefully you're not on boats like that. That's not very good. So this boat is kind of flexing around, but that's because they're different regions, and those different regions don't actually cause any problems. There's never, if you look at it, there's never really an edge that appears where the boat is flexing. So it's just smoothly flexing. And there's really no way to know that that's bad. You could, again, put a stroke here and say, well, let's just make the boat not move. That's one option you have. This one's also fun, too. If you actually look, cars basically disappear and reappear at poles on the highway. So again, there's no artifact there. The car fully disappears, and there's no way of knowing that that's completely implausible, or that a car could, emerging from a pole is completely implausible. So that's just a hard thing to control. This is something where a little bit of input in the beginning, and I'll get to this later, might be interesting. And then there's other things, just motion. So here we have this bird. It moved over during the video. So again, it's still, there's no edge there, but obviously its neck is not really that thin. And there's no way for the computer vision algorithm to know that bird should have a neck that's 5 pixels instead of 2, right? And the same thing here. This person moved, and they get chopped off. You only see the bottom of them. But the thing is, the line where they got chopped off is where they were wearing a skirt already. So there was already a line there. So it basically thinks that that line is totally fine. And the fact that now there's black above it as opposed to whatever their costume was, which was a darker gray maybe, there's no way of really knowing, right? So just kind of wrapping up, thinking about sort of taking a step back from some of these projects. I've been thinking about how do these two things relate to each other, and then just in general, how does sort of HCI and computer vision, what are the ways that they can play well together? And I think cliplets and the automatic looping take sort of two sides of this picture of the scale in an interesting way. Cliplets really mostly relies on the user. And if the user just does something stupid, there's really not much you can do to make it better. If they want to cut someone in half, you can't stop them. If they want to make a loop where Pinocchio looks like his leg's broken and jumping, they can do that. And in a way that's good because it's a creative tool, but it also means it's really easy to create terrible cliplets. So you're relying on the user, and the computer vision kind of just helps a little, blend some things. It makes things a little better, but it can't really overcome that. Then the other project is really now on the other side. The computer vision's coming first. It's really doing a lot of stuff. It's doing all this optimization and giving you a really restricted set of controls. So it doesn't create anything that's really terrible. And in some cases, it actually, a lot of the we run the right thing on a lot of the videos from Cliplets, and they work fairly well. But there's no way in this interface that I could say, I want to pause this girl in midair and have this other boy walk in. And it's very hard to tell anything narrative. So for any of you guys who are sort of in the space of HCI and thinking about computer vision, computer graphics, and also are familiar with a lot of the other work at UW, like Asim Agrawal's work, David Salison, and Michael Cohen, I think there's a really interesting space to think about here. Just where do you put the computation, where do you put the user? And depending on sort of what the order is and how you interleave those, lots of different things could happen. Right? You can imagine a hybrid of this, which is an interface where the user first gives you a couple strokes and says, this thing should move, this thing should move. Then you run this optimization, right, to give you the best loops. And that could act, maybe that's actually the right thing. Or maybe, when you have a big touch screen or a mouse, cliplets is good, and when you have a phone, that's good because you don't have a lot of control. So I think it's kind of fun to think about that. One last thing I wanted to mention, so I kind of talked about, in my title at least, creating and exploring living photographs. I was thinking, mostly what I talk about is exploring in the creation side. But this is actually a paper from Kai last year, which is a little bit of a different take on exploring living photographs. So let me just talk through it. What this is an iPhone. It's using face tracking and gyroscopes on your phone to drive navigating your input. So you can think about, there's so many rich sources of data. We have, our slider on our looping video. We have, you could have, in these cases, you have panoramas, you have a view control. But what we explored is, can you just use your device as a way of controlling your experience with imagery? So this work came before cliplets, and it's not really related, but I think there's some interesting ideas here too, which is, if you have looping videos, you have dynamic things, can you think of, are there interesting ways to explore those axes? So for example, you can imagine as you tilt your phone, or maybe the faster you shake your phone, the more your video loops, right? Or if it's still your phone's on a table for a while, it's a photo. As you pick it up, it starts coming to life. I think there's a bunch of fun things that you could do there. So I just wanted to restart that, just kind of show these things. These two examples are zooming through and navigating sort of the street view stuff in Bing, and then this is actually a 3D data set. So you see here, as you move, it's giving you a different view. So you get this kind of 3D feeling. So that's pretty much it. I'm happy to take questions. Thanks for your attention. You can email me if you're interested in chatting or you have any questions about this. So thank you. Yeah.
For your independently looping regions, can you tag them?
Can you tag them like with text tags, for example? You could. We haven't really looked into that. But yeah, there's no reason you couldn't tag them with data. I don't know that. Part of it is just infrastructure. I don't know what sort of video tagging infrastructure is like. So when you tag an image, well, in Facebook, it just stores it somewhere, right? But you can also store things in an EXIF header. Videos don't quite have this just random header you can shove things into. But yeah, it would be interesting to think about that, of tagging different regions. So yeah, but we haven't really played around with that. One thing we've been thinking about, but we really haven't got to, is also sound. Right, so a lot of these things would be great with sound. And if you look at some of the newer sort of iPhone apps, I don't know if Vine has sound, but there are a couple that do. But so there's a lot of these sort of short video messaging type apps, and some of them have sound, and it's pretty interesting. But it's interesting to think about how sound is completely different. Looping sound doesn't necessarily always make sense, right? So what is the mapping there? But I could imagine with tags, right? Now you touch this thing and it actually not only plays, the fountain, maybe you've recorded this is a fountain in Florence and we had lunch here. And so, it could be kind of fun once you start thinking about this as a way to tell a narrative. And then, yeah. So I think text tags and even little sound tags could be pretty fun. Yeah.
For the last project that you talked about again, the Kai paper, did you look at using I guess you're kind of using the phone as a viewport.
Yes.
Did you look at doing that for document reading or web browsing?
A little bit. So we had one example that I didn't show for a map viewing. So the basic idea is, so it's detecting distance with a face tracker. So you have basically full pan and zoom. So we looked at, it was actually fairly hard to control. That's one of the things that kind of came out of that is like mapping, if for a map, so the map example we had was like, you start in San Francisco, you zoom out, you pan over to New York, and you zoom back in. But the levels of zoom in that, from like a city level view to Earth that you are mapping to this short range, it's really tricky. Like it's really hard to control that well. The panorama works a little better because maybe it's just 3 times zoom. Map is, I don't know, 10 times or something. But we did look at that. I have not looked at documents that much, but I think they would be similar. That might actually be a better case because you don't have, you don't necessarily need as many levels of zoom for a document.
I think that just having to swipe for scrolling is really tiring.
Yeah.
Especially when you're doing it a lot. Like I have RSI because of it sometimes.
Right. Yeah, that's actually what motivated part of that was that project was actually wanting, well, it's not because of fatigue, but we wanted to be able to do one-hand navigation. Right. So like I often walk my dog, holding my phone, reading stuff, trying not to like run into trees, and like I want to be able to not, also have to do this, and I'm carrying a cup of coffee, and so the idea is, could you sort of walk around and be able to just navigate like a web page or an image, or flip through slideshows? So that's kind of where that started. Yeah, we did user studies for that too. It really just comes down to there's a lot of subtleties in how much control. So we looked at how you might be able to slow down. So you want to be able to like move and then stop, right, and not overshoot. Yeah. So kind of explored a bunch of different functions for that. But it does create this other problem, which is you get the gorilla arm problem of like you're holding your arm up like this all the time, or maybe like this is a little better. So you might be trading RSI for arthritis. I don't know. Yeah.
You mentioned that those calculations are computationally intensive.
Yes.
Could you tell us more about the hardware you typically use to produce that?
Yeah, so those guys, it's still not that bad, but it's like I think for processing, let's say that video with the flags or the drummer, maybe 5 minutes on a reasonably fast like quad-core desktop. So way too intensive and slow for a cell phone, but it's not like a cluster of machines or anything like that. And there's a lot of tricks you can do. So like you can compute the loops at a lower resolution than the output video. That speeds things up. But it's a little bit away from the, as you could tell from Cliplets, which is fairly responsive and actually very responsive on something that's more than 4 years old. It's still a bit away from that, and not so ridiculous. Not like you're waiting hours on you need $1 million cluster. Probably, I mean, especially if you're thinking about something like Premiere, which will run filters that take minutes. It's not that far off from that. Yeah.
Talk a little bit about identifying the looping points, because I can imagine something that's periodic. You could decide to loop it when it gets back to a starting point, but it may go past that and come back. So. Yeah, I mean there's some ambiguity. We do look at a window over time, so it will try to match motion too. So like you can imagine something that goes like this. You may not want it to reverse directions in the middle, so you'll tend to try to reverse it where it stops a little bit. But there can be ambiguous points. I mean, there are certain things, like that candle example, right? There's just a bunch of places that you can loop it. We have a couple things in there to try to prefer longer loops. So just little priors that say, well, if things are fairly similar, well then, all things being equal, longer loops are better because you get more variety. That kind of stuff. Are you just comparing features or houses?
It's basically looking at neighborhoods of pixel values. So if you think about your input video, a little cube in space and time for each pixel at the beginning of every, and it's all possible periods. So we saying given all possible periods and all possible labels, there's a cost for making that transition, and then we're minimizing over that.
Okay, we're out of time.
Okay.
So let's thank Neil.
Thank you guys.